test review. 2B test. Yes. Okay, you can't see that. Okay, so let me get that a little bit bigger. 6 questions for you. They seem to be some of the bigger questions that we maybe not miss every single time, but we're not great at yet. So we're not great at these questions yet. So let's take a look at some of those. So the first question, let's call, and go ahead and pause me. Try these questions that you can see, and I'll scroll down in a minute, obviously. But pause me first, and then I'll explain how to get these answers. So number 1, did you pause me yet? I don't think that you paused me. Okay. Number 1, let's call a certain function g of x. I want to know how I get from one to the other. So you can't use Desmos, you can't use all these other things. You need to understand how the functions are transformed in the coordinate plane. How did I get from this to that is my question. So if you're looking at the, I don't know why it's there, right there. So you're looking at the number values that change, right? And this number value that changed is, this one went down, and this one went down by 24 units. There may be some other things going on with here, but we're going to focus on what's just different for now. So what's different for now is that I went down 24 units. So it would be a vertical shift down 24 units. The ones that we've been doing, they're vertical shifts left and right, correct? But this one specifically would be 24 units down. So, yeah. Number 2, you need to know the difference between independent and dependent variables, obviously. So independent x, dependent y, or dependent f of x. So in this situation, what would be independent? Well, each piece of pizza costs $5.50, Domino's, and the delivery charge is $10. So what's independent? Well, I know it's x, but what is x? What does it represent? And in this instance, it represents, well, how many pizzas did you buy? So that would be the independent variable. How many pizzas did you order? If it was me, it'd be like 3, you know, because like that's how I roll. Let's scroll down a little bit more for number 3. Number 3 says, what value of x makes f of x 9 if f of x is this? So this is confusing. What value of x? Okay, so I'm trying to find out what x is. In other scenarios, I'd be trying to find what f of x is, but in this specific one, we're looking for x values. So f of x equals 9, and f of x equals this, 14x plus 2. So I need to set up an equation, and that equation is already kind of laid out for me. 9 is going to be substituted in for f of x, and that's going to equal 14x plus 2. Well, I'm just going to solve this equation, because I want to know what value of x, or it should say what values of x. So I'm going to subtract 2 on both sides, and I've got 7 equals 14x, divide by 14 on both sides, and your answer is 1/2. X equals 1/2. That's my value of x. That makes that true. Okay? Average rate of change on the interval 0 to 5 for the function f of x equals x squared plus 7. You don't need a graph because I'm giving you all the values that you need. When x is 0, where is f of x? When x is 5, where is f of x? And this is a slope problem. You're going to see that often. There's a lot of things with slope on here. So when x is 0, I'm going to plug it into the equation. 0 squared is 0, plus 7 is 7. When x is 5, 5 squared is 25, plus 7 is 32. So there are my 2 points. Now I find the slope. So 32 minus 7 over 5 minus 0. Okay, so that's weird how I did that. Went back to this. 25 over 5, the answer is 5. The average rate of change on the interval from 0 to 5 is 5. That's really strange how that worked like that. Okay, good. Next one. If a function is linear, okay, so it's going to have something that's constant, f of 2, so on the function, when the x value is 2, the function's value, or y value, is at 7. And when f of 4, when you have the x value of 4, I go to 21. So what is f of 3? Again, this is a slope problem, okay? So if it's linear, which is a key, you need to know that it's linear instead of quadratic in nature. I'm trying to find the midpoint here, or what's going on in between. Well, if f of 2 is 7 and f of 4 is 21, I can use slope formula, or I can just kind of eyeball this. Well, I know it's going up by 7 each time, right? So f of 3 is going to be 14, okay? Or I can just use slope formula. So x1, x2, y1, y2. 21 minus 7 over 4 minus 2 is 14 over 2, which gives me, knew I was going to make that mistake. So the slope is 7, but f of 3 is 14 because the slope is 7. So that's confusing, sorry. The slope of the line is 7, but f of 3 is 14 because f of 2 is already 7. So I kind of figured I was going to make that mistake, but I'm glad we did that so we could learn it together. Yeah, f of 3 is 14. We're already on number 5. See how fast that went? Actually, 5 minutes. Okay. This is a good review. These are some pretty good questions. Remember slope. It's going to be all over the place. I want you to find all the characteristics of this function. F of x equals the quantity x minus 4 squared. And I gave you a small little graph. On the test, it will most likely give you a graph. For ones that there is no graph, it will be something that you can solve algebraically. So it's not going to be a big mess for you. That's coming in future years of math. Okay, so I'm going to go through these pretty quickly. Is it a function? Yes, of course it's a function. It passes the vertical line test. Hopefully you pause me and you're not just going over the answers because you're going to need to know this information. Number 2, domain. Well, I can't see the entirety of the graph. You know the y-axis has to be over here at some point. The domain of the graph is negative infinity to positive infinity. The range of this graph is bracket 0, because it actually touches the x-axis, to infinity. So bracket 0, infinity for range. The x-intercept, there is only one, and I know you can see it, but you could tell that there would only be one because there wasn't anything over here. There was no vertical change, vertical shift over here. So 1 x-intercept, and that is 4. Y-intercept, we can't see it, but we know if we want to find the y-intercept, we set x equal to 0. So 0 minus 4, negative 4 squared is 16. The y-intercept is going to be 16. And I can't scroll up because this is a picture. End behavior. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. Hopefully I said positive infinity here. I don't remember. Average rate of change. I didn't give you an interval, and I always miss that. Let's just do the interval from 1 to 6. Okay. So average rate of change, go ahead and try that. I know when x is 1, negative 3, so 9. That's the point on the graph, and I know when x is 6. It actually will pretty much give me that. 2, so it's 4. Yeah, that's right. So it's going to be weird. 4 minus 9, 6 minus 1, negative 5 over 5. The slope is negative 1. The slope of that line, the average rate of change on the interval from 1 to 6 is negative 1. Intervals of increase and decrease. The function is decreasing, beginning or starting on the interval of negative infinity, and it goes all the way to 4. The interval of decrease is from negative infinity to 4. The interval of increase is from 4 to infinity. Keep in mind, when you include 4 here, it is a parenthesis because it's technically not doing anything at 4. It's not going up or down. So the interval of decrease is negative infinity to 4 with parentheses all over the place. The increase is going to be 4 to positive infinity because, again, if I were standing on this function, I'm going downhill, I'm sliding, I'm sliding, I'm sliding. Here, I'm standing straight up. My feet are flat on the ground. The slope there would be 0. I'm not doing anything. Odd even. We all know what that is. I know you're dying for me to do it. Maybe I'll do it in a minute. It's an even function. It's positive. Now here's one thing that we haven't talked a whole lot about, but you can understand it. You can get it from here. This function is always positive. Always, because it's always above the x-axis. If any piece of this went below the x-axis, that piece of it would be negative. So for instance, I'm going to make a small function. So here, let's just say I have a function that's just like this, and it stops there. It doesn't go to infinity. I know, it looks like smiles. Ah, smiley. See, teeth. Now it's angry. It's an angry function. Okay, this angry function, here and here, it's above the x-axis. Those are the intervals of positive positive stuff. Here is where it's negative, because it goes below the x-axis. And we'll talk more about that today in class. Bad function. Okay. So if it's above the x-axis, it's positive. If it's below the x-axis, those intervals are negative. This is a positive function anyway, because it's positive x minus 4 squared. Okay. What else did we talk about? End behavior, average rate change, odd, even. If I missed one, make sure you understand it. I don't remember. We're at 10 minutes now. That's a wrap. So study, study, study. Big, big, big deal. Bye-bye.